So good morning, everyone. And that was Pretty Blue Eyes, and who's doing the honors? Crosby, Stills, and Nash. Okay, Pretty Blue Eyes. I have something on the document cam that just intrigued me this morning over coffee. This is today's date as we go to the document cam, please. 9/23/8. Now it's interesting, and I'm using the 2008 just as 8, that 9 is 3 to the second, so if you take 3 to the second plus 2, you get 3 plus 2 to the third. From today's date, 11 equals 11. So consider the general form where y equals x plus 1. Then we have y to the x plus x is equal y plus x to the y. So the question, how many solutions? It's non-statistical. Well, let's leave it up there for a bit more. It is algebraic, involves exponents as variables. Now clearly, if you let y equal 3, 3 to the second plus 2 is equal to 3 plus 2 to the third. Is there another solution? And are there more than one, or is there more than one solution? And if there is another solution, are those two unique solutions? So if you want something to while away your day from today's date, I'll let you write that down for a moment, just a bit longer, so people can write it down. Let's bring it back up. So write down today's date, 9/23/8. Write it in its form as, I call that a date math day, a DMD, my own version of a DMD. And that means 3 to the second plus 2 is equal to 3 plus 2 to the third. I gave this to Sarah this morning at breakfast for her to have fun with. So that was my gift this morning. So it's y to the x plus x equals y plus x to the y. Again, we know one solution, the ordered pair, okay, in terms of x and y, would be 2, 3. Is there another solution? So with that, we now can come off of it. Back to statistics. Yesterday we did a lab. Are there any questions regarding Lab 6? That's going smoothly. Your homework was to complete the lab, at least the computer presentation. How many have that done? Okay, a few of you. You know, folks, that assignment was given with the idea of getting it done so that you could, today, focus on, in class, the homework on 4 and 5, that by tonight, you can be thinking about the short answer questions we're going to, and start preparing for the test, which is Thursday at 6 a.m. So, the intent of making that assignment was to try to structure your time so that when you get ready for the test, you spent the appropriate amount of time in preparation rather than trying to do an all-nighter before the test. It's a bit of frustration when an assignment's not done as requested. We're going to go to the laptop first, and I'm going to click, go to the laptop, please. And that is the splash screen that we've talked about. I'm going to come up here to the left-hand corner, and what I'm doing at that point is simply highlighting the Math 134 link that we're going to click on. And that should, in a moment, bring us to the splash page for the video-based course, which is also your home page because it has the information for you. And in particular, as we bring this in now, and I'm going to come over and scroll down, we have the schedule for you. Okay, this is coming down now. Fall 2008 on-campus schedule. Now, we have a video-based schedule also, but this is the on-campus schedule. And if I come to that, zoom out so you can see what's there. This is the schedule of sections covered. And of course, as we scroll down here, and I bring that in a little bit tighter, we are now in week 5. Okay, this is indicating the Chapter 5 and Lab 6 and Exam 1 on Thursday, the 25th. So we're clicking there. We've been here before, but just a reminder, I've asked you to look at these. I've asked you to go ahead and note that we have a variety of questions. I believe there's 67 of them here. And these are the short answer questions that I mentioned yesterday. Part 1, 30 minutes, 10 questions, 3 points each. And as you come down this list, as we go to the very end of the list, and the intent is that you have gone through all of those, just looking at the last question. What is a systematic sample, and how do you set it up? That's where we started at the beginning of the semester, and we talked about getting, say, 10 countries systematically. And so the first question, since these are something that you, I hope, have printed out already, are there any questions regarding any of these? The intent was that you might spend some of the time over the weekend on these. Are there any questions from these 67 that you'd like to address? I'll do that today and tomorrow. Thursday, it's too late. Any questions? Erlinda?
49.
Okay, 49 as I come back to the screen and scroll up to 49. It was on my monitor, but let's come back to it. Explain what is meant by the phrase, correlation does not imply causation. Now, this is from your text, and it has to do with birth rates and life expectancy as you think about that in terms of Lab 6. The question, is it the birth rate as such that when the birth rate goes up, life expectancy goes down? Is the impact on life expectancy because of the birth rate? Or is there another confounding variable? What also goes along with that high birth rate? Of the variables we have looked at.
Literacy.
Okay, female literacy, yes. What else? That might be a very
Gross domestic product.
gross domestic product. Do you live in an industrialized society? Do you live in a non-industrialized society? And one that we haven't even measured. There's a very difficult variable to measure called culture. Now we think of it in terms of female literacy because the program of action that's still in effect out of the 94 conference in Cairo was to empower women. That goes against cultural practices in many countries. And we measure that indirectly by female literacy, but the culture itself could be an extreme factor in life expectancy. Okay? So the birth rate is correlated to life expectancy. We saw that at a figure of about negative 0.9. But if we want to change life expectancy, do we just have to decrease birth rate? Now, a simple way of looking at that is to have a war, or genocide, or HIV. Okay, and birth rates may plummet. And what may also plummet? Life expectancy if everybody's dying. So it's not cause and effect, per se. That has an impact, yes. But there are other, what we call, confounding variables. David Moore created a phrase called lurking variables. They sit there explaining what's happening, but they aren't part of your analysis. So bivariate data analysis is contrasted to multivariate. In multivariate, I might simultaneously try to look at birth rate, gross domestic product, female literacy, and I might even toss in infant mortality. causation and correlation are not synonymous. Just because something is highly correlated or related does not mean their causation exists. Okay, other questions on the 67? And by the way, that allowed me very nicely to talk about some of the content we have not covered yet in the chapter 4 and 5 that I wanted to look at. So that was one of the topics for today, which we now have done. Other questions from the 67? Well, 1 out of 67 is not bad. We had 67 more days before the test, we'd be in good shape. Enough said, then I'll come back again. Oh, there's still another one? Okay. 51. Boy, I'm lucking out. I don't have to move anything. Okay, 51. Name 2 measures of central tendency. Now, that is involved with the distribution. Okay, where is the center of a distribution? The mean is at the center, right? Where else would we see a measure of that center? The median. The mean and the median. Which, by the way, is the sensitive one? The mean. And when I say sensitive to what? Extremes, the outliers. That it influences, the outlier will influence the mean where it will not influence the median. Now, if you remove the outlier, you may influence what? Well, you obviously are going to influence the location of the median. But if there is a fairly, how do I want to say this? If you look at the distribution, you look where the middle of it, this is you've ranked or sorted your data, you're going to find that the 2 or 3 values in the center are going to be very close typically. And so by removing the outlier, it doesn't have much of an impact on the median, but it may have a very profound impact on the mean. So we talk about that trimmed data set, where maybe you take the top and lowest value, the highest and lowest, and remove them from the data set, and then recalculate. Any other questions from the 67? Feel like an auctioneer trying to eke out some kind of response from you, going once, going twice. Erlinda.
What is the advantage of the computational formula for finding the standard deviation?
What number is this?
That's number 61.
Okay, 61. I'll just scroll down a little bit more. Okay, it asks for the advantage as we go to the document cam. It asks for the advantage of the computational form over the conceptual form in number 61. Okay, as we come off there, please. Probably the simplest answer to that is that you can use recall keys in your calculator to provide the documentation rather than having to list all of the differences, square all the differences, and divide by n minus 1. So the documentation for providing an answer on a test would be much less with the computational form than it is with the conceptual form. The time would be much less. And, as I hope you reflect on from the last 2 days, that if you have, maybe going back to Thursday, if you have the formula for R, and we talk about the covariance of x, y over the standard deviation of x, standard deviation of y of being our definition for R, then if you know the computational form, if you look at the formula for R, the computational form in the numerator is precisely what you see in the denominator of R. Let's go back to the document cam for a moment. Looking at that, and I'm going to take out of here the formula page because I'm getting a blank look. Okay, what I'm going to do now is come off there for just a moment. I'm going to go to the document cam. Here's the formula for R I was referencing. Now coming back, and let me bring that down maybe a little bit tighter. But notice the denominator of R in those square roots. Those are just the numerators of the standard deviation of x and y. That's your computational form. So again, as you look at the screen, and I look at the 2 radicals in the denominator for R, they come out of Sx and Sy. computational form. So the advantage to that in my way of thinking is it gives you a very nice way of remembering the formula for R. The numerator is the covariance of xy in computational form, and the denominator is just the numerators of sx and sy. Okay, now coming off there for a moment, let's come back to the laptop, back to there. That would be a two-part answer for number 61. Okay, off there now. Questions beyond that? We've had 3 now. That's pretty good out of 67. Only 64 left that you haven't talked about. Okay, going for number 4. 17. I'm going to have to scroll back up to get to 17. Okay, let's go to the document cam. This is number 17. The difference between a suspicious and extreme data point. Okay, coming off there. Well, the suspicious point is between the inner and outer fence, correct? The extreme point is beyond the outer fence. Now, beyond meaning above the upper outer and below the lower outer. So just in terms of the way we define them, there's a difference. What about notation when we try to illustrate them? One's a box, one's a little asterisk typically. Okay, which one's the box? Suspicious point, correct? Beyond that, so we have 2 differences so far. Third difference. An extreme point you're more likely to eliminate, correct? From the data set because of its impact on the mean and the standard deviation. Both are sensitive. The suspicious point you're less likely to eliminate, but in both cases you're going to challenge. But the challenge is, I think, more aggressive when you're dealing with the extreme as opposed to the suspicious. Is that enough? Okay, we've got, I think, 4 we've asked now out of 67. Anybody else? I have 2 people who have been asking. That suggests the rest of you have not been looking and don't have that available. As I look at what's on your table, looks like about 3 people, 4 people have the list in front of you. So may I suggest to you that you print out this list, have it available for tomorrow. Okay, part of your preparation would be to go through these. So we leave that now. My agenda for today, in part, was 1, to ask about the lab. There were no questions on that. 2, was to ask about the short answer questions, the 67 are there. We've done that, and there's been limited participation. So let's go to what also is on my mind, and that is related to the text, some things we have not talked about. And one of those goes back to the question about the relationship of causation to correlation. And just a reminder that one does not imply the other. That is part of the content in the chapter that I had not addressed up to this point. And of course, your text does cover the idea of what we consider influential points, outliers. And so the question, how do you look at a graph and determine where you might have a point that is causing an improper influence on both the line and on your value for R? Where would you look for that kind of information? How do you identify points that should be challenged, questioned? Zambia was the point in question on the lab. How did we pick up on that? What were you looking for?
On the graph.
Okay, which graphs?
The one with the influential point.
Okay. The scatter plot certainly is one place you can pick up on that, because if it is evident that a point does not follow the pattern, that's fairly clear. Where else do we see that information? On what? Well, we didn't do a box plot for x, y, so the box plot would typically be where we'd find extreme points. But what about ordered pairs? Okay, I'm going to come back to the lab for a moment. It's easier to do that than it is to respond to doing something by hand. But what I'm going to do is come back to stat graphics, and I'm going to try to illustrate in this process something that I did yesterday as I saved things. Let's come back now to the spreadsheet. Now what I did yesterday with our data is save what we had done as a statfolio. So I saved my data file as lab 6, and I saved my statfolio as lab 6. So I'm going to come back up here and just go to open. I'm going to go to open the statfolio. And my choices here from yesterday that I did, you'll see the lab 6 up there. And if I just click on lab 6, double click with the left button, I will open that up, and there's my entire analysis from yesterday as we left it. Now this, of course, was the plot of the fitted model, and this was with what? As you look at that, what would be your choice here in terms of acknowledging what I have there? What would you say? Is that with or without the IP? Ouch. Okay, I'm going to bring up the data file, which was lab 6, and let's see what we have there. As I bring this up now, only 9 data points, correct? And so that was without. Now I'm going to go ahead and enter the data for Zambia. I need your help here. What is the ordered pair for Zambia? I don't have that sitting here in front of me. I've rearranged. What is it? 4852? 4052. Is I'm hearing that right? And then the related LEF? 38.7. Now I'm just going to enter that information, and I'm going to come back to the top here where I go to the window, and I'm going to come down to my simple regression analysis. And remember, when I do this, what I see is now everything adjusted for what? Everything's adjusted. Now how am I going to pick up on that? Let me see if I try doing an overscan there. See if I can move up. I can't do anything there with what I have on the screen. So I'm going to make this smaller, and then see if I can come. What I was wanting to see down here was that we had this point, and that's your IP, correct? Now I'm going to zoom out and try changing that much. That was our complete model. Now I'm going to come up here where we talked about this yesterday. I'm going to look at my analysis toolbar, and I'm going to go to tabular options. And remember, when I came to tabular options, I could go ahead, as I selected yesterday, and get influential points. Now the question, could I do something else coming back up here? I'm going to cancel this because I've already done that. I'm going to come now to graphics options. And when I see the pop-up here, I can get what we did on paper, and this is a residual plot. So I'm going to take residuals versus X. That's what we did. Remember, we plotted XE, and I've told you that I'm going to expect that on the test. And we looked at fanning out as accuracy. Now, as I look at the residual plot, am I getting what I wanted in that residual plot? And that is a sort of random process as I look at the points, and the answer is no. I'm going to come down now just a little bit, and do you see in the residual plot the IP sticking out, that outlier being very different than the rest of the plot? Residual plots will give you a way of obtaining residuals that are unusual, and those are points that are unusual that go with what is termed an outlier. So your residual plot is another way to get a point that is having a very strong influence on both R and the slope of your regression line. So that's something you're going to be hunting for in your test as you look at the residual plots. And we said, in addition to that, and this gets back to that residual plot we had for this data, bringing this back up to the screen. This is what we did in preparation for the test. These were the XYs, if you'll remember, as we come back to the document cam. And this was taking 6 countries, one from each of the continents, and we ended up with an analysis carrying this through. And if you remember, carrying this through, you had the summation of E was 0, and you had the summation of E squared was 84, and I asked you to get R out of this. And then we went ahead and looked at the residuals. So these residuals here, as we come through now, looking at them again, and remember you would plot X against E. These are your E values near in the center of the screen. And that negative 685 was what? Quite a bit different than the others on a residual plot and might be considered a what? An outlier having a very definite influence on what we were doing. Okay, so again, residual plots, outliers, and the impact. And what David Moore has you doing in the homework is recalculating R when you remove data points and asking what's the impact. He has you looking at the slope on removing certain points. And that was part of the homework I gave you. So, again, the residual plot allows you to do 3 things. 1, to determine if you've met the criterion for bivariate data analysis. And the criterion with residual plots is first that the average residual is 0 and that the residuals are randomly distributed above and below the baseline. So we're going to plot XE. So you look at E equals 0 and you ask, are my points randomly distributed above and below? If you see a pattern such as fanning out, or you see a pattern such as a parabola, it suggests you have trouble. If the residuals are fanning out to the right, then that means as X gets larger, your accuracy is less. If you have a parabolic shape in your residuals, that means you did not have a linear relationship, and so your linear model is not appropriate. If in the residual plot you find one residual very removed from the others, that suggests an outlier which could be an influential point, having a very profound influence on your analysis. Then you have to make a judgment to keep or throw out that point. That was the entire issue in Lab 6. Okay, those are a couple things that needed to be added to our discussion from chapters 4 and 5. Now, homework, chapter 4 and chapter 5. That's part of what I wanted to come back to and spend some time answering questions on homework. So starting with that, do you have any questions that you would like to address from the homework? Okay, while you're looking at that, let me come off of the stat graphics, bring back up what we were doing. And what I'm going to do is come back to the homework assignments in the 4th edition. That's what I'm doing now. So let me bring that up for you. Take just a moment, and then I'll show that on the screen if our server for bringing up another web page. Okay, this is a bit unnerving when it's not working as quickly as I'd like. There we go. So let's come over now to chapter 4. Let's bring that up on the screen. These were the questions on chapter 4. Anything from there that you've done, you've worked on, that you have questions on? Yes? Number 8. Okay, so that, I need a page number for, please. Page 100. So let me open the book and get to that page. Okay, I'm at 102. There's 100. And an interesting topic of research, because most of you know about some of the research done on coffee. What's the usual research done about coffee? the effects of caffeine. And you, I assume, know that there are some pros and cons. What are some of the pros for coffee from the research for older people? What? Well, there is some question of whether or not it has an addictive process. But what is the pro for coffee? I don't assume you would consider addiction a pro on coffee for older people. What is it? Okay. A pick-me-up, headaches. Some research suggests you should have a cup of coffee at your bedside, drink the coffee before you get up so you don't trip over and break your hips. The idea that it's a nice wake-me-up and gives you a little more alertness because there's a lot of potential for getting out of bed, stumbling, and then bones are brittle, so you fall down. Just in the last 48 hours, and all I can tell you is there are 4 papers that we get in the morning. So this is in either Modesto Bee, New York Times, San Francisco Chronicle, or Wall Street Journal. That's where it's located. But there was a recent summary of the benefits of caffeine. More benefits than negatives. So we usually think in terms of caffeine as a health issue before Starbucks. Then it becomes an economic issue. Can you afford the $4 or $5 venti latte? Question, of course. Now let's go to the text. Here's a new one. Coffee and deforestation. Now just with that much said, how does that affect the world population in crisis? Because it's an issue. That's why I chose this problem as we come off of it. Deforestation, where? Okay, could be Indonesia, but that's not the hot point, the flash point involved. Rainforests? Huge country. Brazil. What's happening?
They're chopping down the trees.
They're cutting down the trees to plant other crops. And why is that a problem? What do the rainforests accomplish globally?
Purifying the air.
Okay, purifying the air, removing the CO2, and if you cut down the rainforests, what are you contributing to then? The global warming. Now, that took some pulling teeth. And that's a major crisis, is it not? And we see Al Gore being a major force in that, bringing it to the awareness, gets an Academy Award, and gets what? Okay, funding. More important perhaps than the Academy Award in your resume? Nobel Prize? We are aware of that, I trust. I mean, Al Gore is one of the people I quote in the intro in the first lab, and he has tried to bring an awareness of our very central problem, of global warming, which some people would argue has to do with the intensity and the frequency of what? That has been a major issue in the last several weeks. Former President Eisenhower, Ike, Hurricane, Galveston, Houston. Okay, there is a world out there, folks. Yes, worth studying, and that's what we're talking about. And so the argument is, as Starbucks expands exponentially, Starbucks in every corner, everywhere, they are buying up more coffee, correct? So as you buy up more coffee, what happens to the price of coffee? It goes up. Then it becomes what? Like corn in the United States for ethanol. Folks, have you driven out in the countryside around Modesto this late summer? Now, some of those fields are now chopped down, but corn everywhere. Why? Because the price is good. The price goes up, you plant it. You should rip out orchards, plant corn, ethanol. Capitalism, the American way. Okay, so you raise the price of coffee, people are going to do what? Tear down the forests, plant coffee beans, because the demand's there. You didn't realize that your interest in coffee could have such a profound effect. Well, here's the price per pound, and here's the percent of forest lost. Sort of like the price of oil on the impact on your driving. Okay, as the price per pound has gone up, the percent of forest lost. And by the way, do you regain it very quickly? Yeah, not very quickly. So notice we have gone from 29 cents to 72 cents, and we've seen the percent go from a half to 1 to all the way up to 3.5, or 3.1, I'm sorry. And what does it suggest? Positive or negative association? Positive is one goes up, the other goes up. Question? Okay, now in part A, it says make a scatter plot. What is your explanatory variable? What's the key for an explanatory variable? X. Explanatory. X is explanatory. Nice little key there, listening to the words. What kind of pattern does your plot show? Did you plot it? Did you do the scatter plot with X, Y? Does it suggest a somewhat linear relationship?
Yes.
I hope so. Find the correlation step by step, coming back to the problem. Step by step, what were your choices? If you're going to do it step by step, following the little bouncing ball, what's your choice as we do that? Two formulas, correct? You can do the computational one, or you could follow Zx, Zy, summation of Zx, Zy over m minus 1, and set up a table. You were supposed to crunch it out. Next. And by the way, that's the 5 standardized values. That was Zx, Zy. You're getting standard scores. That's what the notation's referencing there. Was there a problem with that?
Yes.
You didn't like doing it?
I was confused as to what exactly.
A standard score. Remember yesterday we talked about the standardized t-values? The idea is you're going to take x minus x bar over s. Here you're going to take x minus x bar over s sub x and take y minus y bar over s sub y. Those are called standardized scores, standard scores, z-scores. That's what I alluded to in our presentation. So you get a zx and a zy. You take the product for every ordered pair. You add up all those products, divide by n minus 1. You have R. Now, are you obligated to that? No, you could have done the computational form and made your substitutions. Your choice.
But isn't that 8C, like AB, they make you do the one way, the C?
No, C is enter it in your calculator and get the value. No documentation. Press R. Do you get the same answer? I hope so. That is a very good problem to practice for the exam because you're looking at how many points in the exam for what it asks you to do. Potentially. Could be as much as 30 points if you carry through that problem in the spirit of the exam. In the spirit of the exam, you not only do the scatter plot, but I ask you to do what? After you've done your scatter plot. Draw the line you think fits the data. Now, if you've done that problem, try drawing your line through the data as you think it should be for your scatter plot. This is on problem number 8, page 101. You have a scatter plot. Try drawing a line that fits your data. If you would, please. And by the way, you will need a straight edge for what you're doing. Okay, and we're going to momentarily go silent here because I've gone to a red dot. So silence will ensue momentarily. You're now green line again, so I feel ecologically I'm green. Ecologically sound, and such is modern technology that I shut up when the battery goes down, put a new battery in, that may make me robotic. Now, have you drawn your line? Got a line drawn? Daniel, let me see yours. Let's see what we've got. So I'm going to share a line drawn for a set of points, and we're going to critique. Nicely done as far as a scatter plot. Very neat. I'd expect this kind of work on a test, so let's go to the document cam. There are my points. There is my line, and I would critique pretty close in the sense that if we look at the verticals here, so here's a vertical, here's another vertical to the line. Now those two are a little bit large, right? But notice this one's modest, this one's about balanced, and those three sort of balance what we have there. I'd say that's done very well. Now question, are any of the points on the line? No, and that happens. How would you get, now that, by the way, for what we've done there, coming off that now, would be 10 points. Well, 8. We need the equation. So what has to be done here is to try to get the equation of this line to get the full 10 points in the problem. So that would be slope and intercept and write the equation. So the points have been plotted very nicely, labeled nicely, line looks good, acceptable. How am I going to get points on that line? That is the next question. So as we come back to that diagram, what I would be inclined to do, since none of the points are on the line, is maybe take it at 40. So just come vertical at 40 and see where I'm crossing the line. So I've done that with that card. I'm going to slide over, so I'm at 40 with the vertical. And then I'm going to take another card, and I'm going to come across horizontally where I seem to be meeting the line, at about there. Now as I do that, you can see that this is coming across at about what? Right where that point is, which is a 1. So it looks like 40, 1 is one ordered pair. And I'm going to play the game again. So Daniel, will you write that down for us? 40, 1. And then I'm going to come over on this line to maybe, now here's 70, a little bit further. There's my vertical, and then I'm going to bring this across horizontally. And at 70 coming across, it looks like I'm going to be at about a 3 point what? What would you estimate there? I need to get that so it's more level. Does that look better? About 3.3, 3.4, somewhere in there. Looking at the distance, I'm not at 3.5, maybe a 3.3. So it looks like maybe 70, 3.3. So I have two ordered pairs. Do you see how I got those? I'm using these cards rather than a ruler to show you how I got the points. Now, if you have points that actually fall on your line, all the better. But we don't. So what would I now do with those 2 points as we come off there for a moment? What would I do with those 2 points? Okay, I have 2 points. I'm going to go to the board now. So as I go to the board, I'm going to go to a slope formula, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. The 2 points I have. Now, Daniel, I need your help here. P1 was 41, is that correct?
Yeah.
So 41, 1. And P2, I believe, was a 70, and then what did I say, 3.3. And that was an estimate on my part, correct? But those are my 2 points. So I'm simply going to substitute into the slope formula. So I have a 3.3 minus 1 over a 70 minus a 40. And so that's a 2.3 over a 30. And what do you get in your calculator as you do that division for me, please? So M is what? 0.77. Okay? Now, I don't have an intercept yet. I could just go ahead and say y minus, and I think I'd take this one. I like that 1 better than either 3.3. So y minus 1 is equal to 0.077 times x minus 40. Okay, so at this point, that gives me y is equal to 0.077x. Then I have a plus 1 minus, and so I'm going to have a 0, a 28, a 30. So it looks like a 0.30. Is that correct? No, wait a minute. I'm at 1%, so that would be, yeah, about 0.308. If I had done that correctly, and so 1 minus that. So it looks like my y value is 0.077x, and somebody correct me if I've done the arithmetic in my head there incorrectly. Are you in agreement on this product of 40 times 0.077? Let's see, that would be 7%, and 10% would be 4. It must be 3.08. So negative 3.08, and so I have 1 minus that, so a negative 2.08. Do we agree? You've got the calculators. I'm just mucking through in my head. Now, that would be 10 points for the problem with what Daniel's done. Now, what would I be interested in the part C? You did part C for this. Now, I don't see that on this paper particularly, but do you have it on the paper there? So you would enter the data into your calculators. Anybody done part C? And share with me what your calculator gave. 0.95 for what?
For R.
I don't want R. I'm wanting a regression line. You didn't ask for that, so do you have it in your calculator? I want the regression line. Okay, you've got your data. Put the data in your calculator, please. That'll just take you a few minutes. Good practice. So enter these. How many values do we have? 5 values. So that's good. So I'll give this back to Daniel. Thank you for sharing that, and very nicely done in terms of the work. For those of you at home with a calculator, here are your data values. We'll put those back up for you. So we go to the document cam, please. And I look at those values, and so my question. Just leave that up there. I'm going to try to have you find for me the regression line, because this would be what I would expect of you as we think in terms of a test problem. And I'm carrying this well beyond the question that was asked. But what is your regression line from the calculator once you enter the data from those 5 data points, leaving that still on the screen for those of you at home wanting to participate in the fun this morning? Still waiting for the calculator's values to be entered. This is something you want to practice, so you do this quickly. Have we got a value yet for me? Somebody done? No, I still see buttons going. Okay, I see some stop. Let's go to the board now. Sean, I see you stopped. What do you have for y as you need a slope and intercept? So you remember you had to go to the A and B key. So you're going to recall A and recall B. So just tell me what you're recalling.
Recall A would be negative 0.976.
Okay, so I was off considerably in terms of my intercept, correct? I had negative 2, and this says basically to the nearest tenth, negative 1. So I'm off by 1 on the intercept. What do you have for the slope? 0.054. So in terms of the line, a little more shallow than quite as steep as Daniel had it. Is he in the ballpark? Would I give full credit? Yes. He's in the ballpark. So this is the y hat contrast. This is Daniel's based on the line he drew as I interpreted it. And this is what the calculator gives. Now note, if I had, and I said this was about 3.3, correct? Had I gone to 3.2, 3.2 would have left a 2.2 here, which is a little smaller in absolute value. And so I would have had something that as a slope would have been a little less. What do we get with 2.2 over 30? What would that become? 2.2 over 30. 0.7 what? 3. So this would have been a little lower. It would have been 0.07 instead of 0.08. And this rounds off to 0.05. So I'm off by 200ths. Okay? Now, again, Is Daniel's line acceptable, and is his equation acceptable? Yes. Now, you were asked to get R in terms of this problem, so let's go ahead and just ask relative to this problem, and this is number 8. This is 4-8, I believe. What is the value of R that you get from the calculator? Sean, since you had that number there ready to give me earlier, what do you have for R?
0.955.
Now, is that a strong correlation? Argue for it, one way or the other. Okay, yes, that was an answer, not an argument. Now, can you give me the argument?
Close to 1.
Okay, it's close to 1. Give me a better argument. R squared is what?
Is
91%. Do we agree? B squared, 0.9, nearly 96. Roughly 91%. 91% represents what? What does R squared represent? Oh, here we go again. Is it going to be read, or are we going to do it without reading? Without reading. Okay, try it without reading. The percent of the variability of y explained by the linear model. Very good. Without reading. Very good. That's called the coefficient of, or Linda gave it yesterday, determination. Okay, we're doing well. 4 of us. But notice, with 4 people doing well, I feel very euphoric. I'm hoping that more than 4 do well on a question like this. Now, back to the thing that seemed to be bothering some of you. I believe this is, oh boy, that was bad on my part. I was thinking z, and so I wrote z. 1 over n minus 1. Okay, I'm going to try to clean that up. So, r is equal to 1 over n minus 1. And then we have what? The summation of x minus x bar, y minus y bar, and we said that was going to be over what? S sub x times S sub y. I believe that's the way the formula is done. Now, I said this is the value for R from your book. It's not the one I have in the handout. This is in your text. This is the way David Moore introduces the idea of a correlation coefficient. Now, I ask you to parse this out and note that if I look at this summation, it's really just z for x and a z for y. Because x minus x bar over S sub x is called the standard score for x. Y minus y bar over S sub y is called the standard score for y. Hence, I believe the phrase used here is the standardized values for each variable. Okay, there's your standardized value for each x, your standardized value for each y. You to take the product. That's what you get here. Then divide that by n minus 1, and you have R. That's an alternative. That was the step-by-step process that David Moore expected you to carry through. Now, in contrast to that, you have a computational form that is not quite as tedious. That is where we traded this off for what's in that handout I gave you, where we have the summation of the xy times n minus the summation of x times the summation of y. That's just that covariance now as a computational form. And then you have the standard deviations of x, so that's n summation of x squared minus the summation of x quantity squared, and then the second radical in the summation of y squared minus the summation of y quantity squared. And this gets back to Erlinda's earlier question. What is the advantage of a computational form? Here you can run column after column, differences in standardized values, and take the products and add them all up, or enter your data and do what? Recall, 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 another recall, recall, and like the governor faced this last couple of weeks, recalling as a possibility. Again, you could go ahead and use your calculator to do the documentation and give me your answer.
Can we use those whenever we want to? Do we always use the computational form, or is there cases where we'll have to use either?
There will not be cases where you have to use this, and you can always use this. I think that was, in essence, a paraphrase of the question and the answer I'm providing. Well, that took one question from the homework, but it allowed me to cover what? 20 to 30 points on the test. What would still be required here to get 30 points in the test? You would need your E's, your residuals for each ordered pair. Otherwise, you have your equation. So you have y and y hat. You get the residuals, you square the residuals, and then I would expect you to use, now here's where I would expect you to get r squared by SSR over TSS using your information about SY. I need that down a little bit, please, to pick up the formula. Now, I only need to go down, not zoom. Okay, so drop down just a little bit. There we go. A little bit more. Thank you. So we have SSR over TSS. So I have this formula, and that's where you need the summation of the E squareds. Because you need to have that SSE, and this is just a formula review in the last very little time I don't have. This is the summation of the E squareds, and where you have SS, well, say TSS, is equal to SSR plus SSE. You have these two, and you solve for this, and use it down here. So with that, I think I'm down to no time. So let me get out of the way. I'm going to come back to just see. Okay, let's go back to the board just from where you were. That's what you're going to need. And then what I'm going to do at the time I have left, about a minute, we're going to go to a slide. Come back to me now, please. And we are going to go to the slide of music in a moment, reminding you that take time to finish out the homework. See if you have further questions. I'll continue that tomorrow and the short answers. Now, we started out with cross